The purpose of our next example is to introduce another type of collection that you can use with linked objects to perform link manipulations. In this example, we'll be taking a look in particular at the so-called list collection, which is one of many generic collections that are defined by the .NET framework in the namespace called system.collections.generic. So these are the predefined data structures that you can use in your programs. The concept of a generic data structure is one for which you specify at the time that you create the data structure object, the collection object, what type of objects are going to be stored in the collection. In this example, we'll be manipulating a so-called list of string objects. Now, in the early days of .NET, the collections that were available to you did not allow you to specify in advance what type of objects would be stored in the collection. And what that meant was anytime you retrieved an object from the collection, you had to know in advance what the type of the object was so that you could apply a cast operator to what you retrieved and then call appropriate methods on that object. With generic collections, because you state in advance the exact type of object that you're manipulating, anytime you place an object into the collection, it's going to make sure at compile time that it's the right data type, so the code won't even compile if you're using the wrong data type. And at runtime, anytime you get an object out of a collection, it's going to give it back to you as the appropriate type so that you can immediately manipulate it in the correct manner. Now, generic collections are interesting in that they focus on how to store data and how to manipulate data and not on the type of the data that's being stored or manipulated. So I, at line 11 here, am creating a list of strings called items. I can also go ahead and create lists of other types. For example, I could create a list of employees. And when I create a list of employees, I can only place employee objects into that list, and I can only get employee objects out of that list. When I create a list of strings, I can only place string objects into the list, and I can only get string objects out of the list. So this list of strings called items is what we'll be manipulating in this example. Now, anytime you're going to use a new class for the first time, one of the things that you should do is go to the online documentation for that class. So I'm clicking in the list class here, and I hit the F1 key to bring up the documentation for class list. And I always recommend that when you go to the documentation, you scroll down, read the information that's provided, take a look at all the constructors available, all the properties available, all the methods available, etc., and get a sense of the complete capabilities of the new class that you're using. In this example, I'll demonstrate several new capabilities to you as part of our introduction to the list class, but you should take the time to look through the list class's documentation. Now, the reason we're introducing the list class here is to show you that link can be used not only with built-in arrays, but also with these predefined data structures that are part of the .NET framework. And in fact, it can be used with anything that is an IEnumerable object. And if you look at the syntax here for the list class, one of the things that you see is that IEnumerable of angle bracket T angle bracket that was popping up in some of the tooltips that we showed you in the earlier examples of this chapter. Even though we haven't covered inheritance and polymorphism yet, we'll look at those in some subsequent lessons. What I can tell you is that the notation you're seeing here means that a list is also something that is IEnumerable. And as such, I can use a list with the for each statement, and I can also use a list with the link capabilities that we've introduced to you so far. So let's go ahead back to the IDE and take a look at this example. Line 11 is creating a list specifically to store strings. You specify the type that you want to place into the list in the angle brackets following the name of the class. And this is an indication that list is one of the generic classes. Anytime you see a type name followed by angle brackets, it's a generic type, and one of our subsequent lessons will also be used to demonstrate how to create your own generic methods and types as well. When you create the list, you have to say new followed by the type of list that you're creating. So new list of strings is going to create a list object that's only capable of storing strings. and the empty parentheses here indicate that we are just asking for a default list, an empty list to start out. Note that you could also declare this by just saying var here, and because of what's used to initialize the variable items, it would automatically be able to tell you that that items is a list of strings, because I'm saying to create a new list of strings, and many people will write the declaration of the variable as you see here now on line 11. I'm just going to change that back to the way it was. Now at line 13 we show you how to add an item to the list. The add method is going to append whatever string you give it to the list called items. And so this list was initially empty, so now red is the first item in the list, and lists are indexed from position number 0 just like arrays are. You can also place elements into a list by using the insert method, which allows you to insert the item at a specified index number. So because we're saying to insert at index 0 the string yellow, the list at this point is going to be the string yellow followed by the string red, because we just placed yellow in front of red. Now to show you that, we go ahead and output the items in the list, and for this purpose we chose to use an indexed for loop so that we could introduce the count property of the list class. And as I hover over that, you can see that it tells you the number of elements that are contained in the list on which you call it. So because there are currently 2 items that we've inserted into this list, we expect this loop to iterate twice and show me what those items are. And notice with a list object that you can index them with the square brackets operator just like you can for an array. So if I stop there for a moment and run this program, we can see that the list contents so far are yellow followed by red. That's the first line of the output that we just produced here. Now, the other thing we wanted to do was demonstrate to you that you can use a list object with a for each loop. And because lists are enumerable objects, you can walk through them with for each. So items is my data source in this case. You can see it's a list of strings, and therefore item is going to be one string from that list of strings, and we're going to output the items. So we're displaying them in this case with a for each statement, and if we look at the second line of the output, you see we get the same list as up above. Next we're going to add a couple more strings to the list, green and yellow. Again, add is going to append the items, so green will become the third item in the list and yellow will become the fourth item. And after appending those items, we're showing you that the list is growing in size here, so we output the values so far, and if we stop there and look at the third line of the output, you can see yellow, red, green, and yellow once again. And the next thing we wanted to do was demonstrate the remove method of class list. And if I hover over remove, you'll see that it says it removes only the first occurrence of a specific object. So basically this is going to perform a linear search through the items collection, and as soon as it finds one that contains the value yellow, it will remove that item if in fact there is any item containing the value yellow. So if I go ahead and output the results after doing that, we can see that after removing the first instance of yellow, we have just red, green, and yellow remaining. You can also remove items at a specific position within the list. So that's going to cause the index numbers for all objects that were after that position to change in the list. And all of this is going to be done for you underneath the hood. So when I say items.remove at 1, that says to go to index number 1, which of course is the second item in the list, and remove that item. So you can see after doing that, that the list now contains red and yellow because the value green was removed from position number 1. And this loop is just displaying those results. Continuing on, the next thing we wanted to do was introduce to you the capability of using the contains method, which simply says whether or not an object is in the collection. Again, this is going to basically perform a linear search, walking through the container looking for that item, and if it finds that item it will return true, and if it doesn't find that item it will return false. So we're using this in a conditional expression that's either going to output the empty string or the string not, depending on the value returned by contains. So it's asking whether or not red is in the list, and when we take a look at the output, we see that indeed red is in the list in this case. And finally, we wanted to show you the count and capacity properties of a list. The count property is going to return the number of items in the list right now, and the capacity property tells you how many items you could put into the list without it having to grow. So right now the total number of items in the list is 2. Its capacity is 4, so we can add 2 more items to this list before it will need to grow dynamically. So these are just a few of the many capabilities of class list, and what you'll find, by the way, is that many of the predefined data structures in the system.collections.generic namespace have similar or identical methods, and the main difference between some of these collections is just how they store data on disk. So sometimes you'll have linear collections, sometimes you'll have tree-like collections, and depending on what the data is that you're manipulating and how you want to manipulate it, you'll make decisions as to which collection makes the most sense for your type of application.